All right, so I'd like you to go ahead and try number 13, the ACT score, and number 14, the Hatchery Fish. So go ahead and pause the video. Just keep swimming and trying the problems. Okay, so hopefully you had some luck with those. Let's go through them. Same as before, I'll go through the answers, and then if you feel comfortable, you can go ahead and stop the video, or if you'd like to watch me go through the tech part, you can do that as well. All right, so for 13, part 1, for a single student, I have a distribution that is normal, 18.6, with a standard deviation of 5.9, and I got a probability here of 0.3421 or 34.21%. And then we took a random sample of 50 students. So now my distribution is still normal with 18.6 as the mean. My standard deviation is now 5.9 divided by the square root of 50 for that sampling distribution. So it's normal, 18.6, comma, 0.834 for my sampling distribution. And then that probability changes to be 0.002 or 0.2%. So that's less than 1%. And then on the hatchery fish, we are assuming that these lengths of these fish are normally distributed, and I will double check that on the test to make sure that I've listed that on every single problem. So you don't have to worry about that if the sample size is 30 or larger, because the central limit theorem kicks in there. But if you're looking at a sample size less than 30, you do need that initial distribution to be normal there, okay, for that sampling distribution. All right, so I have normal 15.2 for that distribution, which gave me a probability of 0.3829, so 38.29%. And then now we have a sample of 9 fish. So my sampling distribution becomes normal 15, 2 divided by the square root of 9. So that's normal 15, comma 0.67. And that gave me a probability of 0.8644. or 86.44%. And then on part 3, now I've gone up even more. I have a sample size of 36. So my distribution, my sampling distribution is normal 15, 2 comma square root, 2 over the square root of 36. So that's normal 15, comma 0.33. And that gives me a probability of 0.9976 or 99.76%. Okay. So what's going on here is that we're looking at, here's my 15, we're looking at this probability that we're between 14 and 16. And as my sample size increases, what happens is the variation or my standard deviation is getting smaller, right? So all my data is getting pushed more towards the center. And so these probabilities are getting bigger because the amount of data between 14 and 16 is getting bigger. Okay? So that means there's less data out in the tails. So if I was interested in the probability that the fish is greater than 16, as the sample size increases, that probability is getting smaller and smaller because that data is getting crunched in the center. Okay? So hopefully as you do some of these problems on the homework, you'll start to kind of see how that's working, how that data piles into the center as your sample size increases. All right, so if you feel comfortable with this, feel free to stop the video. Otherwise, I'm going to go ahead and go through the tech part of that for those of you that are interested. All right, so let's look at the tech part. Let's go back to number 13, the ACT scores. So we had a mean of 18.6 and a standard deviation of 5.9. And we'll click Scale to Fit. And then I'm interested in a score over above 21. So I'll put 21 in here. And then I'm going to flip my inequality over. Okay, and there's my probability of 34.21%. And then if I go to a sample size of 50, what that does is it changes my standard deviation. So I'll change my standard deviation up here to be 0.834. And now the probability that the average score for those students is 21 or higher is there's my 0.2% right there. And then for the fish hatchery, we started with a mean of 15 and a standard deviation of 2. And we were interested in fish that were between 14 and 16 inches. Okay. And when I hit enter, we get this part in the middle lined up. And here's my 38.29% because we're interested that they're between those. Now, if I move to a sample size of 9, that changes my standard deviation to be 0.67. So I'll change my standard deviation and click scale to fit. So now my probability is 86.44%. And then if I move to part 3 with this sample size of 36, my standard deviation changes to be 0.33. So I'll change that as well and click scale to fit. And now I get that probability, the fish, or that average length of the fish is between 14 and 16 is 99.76%. All right, so I hope that this is making sense, but if not, please reach out to me and let me know. I'm happy to help you get this all figured out.